Thank you very much. My idea is just about, just like the former lecturers, about belief and some cognition. But my research is rather very simple. Because we're now in the computer science or quantum mechanics, there are widespread usage about the modular logic and the modalities. But some friends, both in the computer science and in economics, told me they are worried about the disunit between the modular logic and the classical logics. So, for example, in the philosopher Quine's argument against the early modular logic is very spread. In the modular logic, and many other kind of intentional logic, there are the failure of the principle of substitutions. More research shows the cause of the failure of the principle of substitutions in the modular context and also mainly in classical logic, because this logical system are intentional logic, just not like the classical logic is extensional logic. And especially modular logic research the non-functional, non-choose functional operator and the non-choose functions. So my idea is what the deeper difference between the non-choose function and the choose function. Yes. Although there are not very few papers, studies between the difference between the non-choose function and choose function, but I have not found another papers beside my papers show the transformations between the non-choose function and choose function. Okay, this is my my central ideas. For example, in my papers, this formula is just from the Quine and another logicals. Yes. For NA6 and X and NY, if X equals Y, then psi X equals psi Y. This formula is valid, but have a premise. Premise is psi X is a function of X. Psi Y is a function of Y. But in the modular logic and many other unclassical logic, some complex sentence or complex formula is not the function of the variables. Okay, so in the modular logic, this formula is not valid. For example, in natural words, we can relate the argument from the Quine. The number of planets is 8. In the original paper of Quine is 9. But we know today's number of planets is 8. Okay, the number of planets is greater than 7. 8 is greater than 7. 8 is necessarily greater than 7. The number of planets is necessarily greater than 7. Of course, we know the sentence 4 is true, but 5 is not true. So therefore, there is a problem start. The same value, choose value of the two directly corresponding causes in two complex sentences which have different choose value, else in which they are only joined by the same connectives necessarily. Okay. Even though this paper had studied the detailed difference between non-choose function and choose function, or difference between non-choose functional connectives and choose function connectives, no one recognized the equivalent transformation between them, nor do more refer to give such transformation a tightly clear definition. Okay. Generally, we think any variables P, for example, and P1, which are independent of each other, are two basic choose functions. However, when P is true, P1 is not only a choose value either true or false, but the two choose value true and false correspondent. So true 1 is not a choose function of P. This is not to say where P is choose, then P1 is both true and false at the same time, but to say that P and P1 has a relation of non-choose function, which can be both hold. When P is true, then P1 is true, and P is true, then P1 is false. This situation is much like the general mathematical relation of two variables, x and y equal y squared. The relation x equal y squared is hold both when x equal 1, then y equal 1, and x equal 1, then y equal negative 1. Of course, when we think about P1 is a non-choose function, especially is a choose non-function of P, we only use the formal nature of modern mathematical logic. Yes. So I try to construct a system like a modal logic. My system name is STRF. Only added a symbol to language is classical propositional logic system CP. But unlike the modal logic, the symbol structure only added can be entirely defined by the symbol in CP. Therefore, the new system is actually still CP. My first point is, first idea is this since the main difference between classical logic and non-classical logic, for example, modal logic, is the former is about the choose function. The later modal logic is about the non-choose function. So we should beginning with the most simple non-choose function. Okay, so this 1, 1, 1, 2, 1, 3 is just the basic symbol in the CP. In ACP, we only added a symbol H. Definition 1 is HP for any atom proposition. HP can define P1. So, although 16 unary operators can be recursively defined by this set. And how about the P2, P3, P4? It is just the HHP can define P2, because HHP is HP1, so the P2. HHP is defined P3. Okay. In this system, so we can define some just the syntactic representation, and about the semantic representation is just the same classical CP system, but another right way, negation and destination. So now we then think about this one. According to structure, no matter what P1 exactly is a non-choose value function of P, that is HP equal P1. If P equal 1, then HP is 1, common 0. This is shows that there are two possibility of assignments. Then HP is 1, common 0. Then HHP is 1. Then if HP is 1, then HP is 1, common 0. So, and we can order two formulas A equals P, B equals HP, obviously A and B are two different formulas. But when P is 1 and A is P is 1, B is HP is 1, comma 0. HB is HHP is 1, comma 0, comma 1, comma 0. This shows that the result can be satisfactory when A equal B equal 1, HA not equal HB. To accommodate this result, according to checker, HHP in context can in syntax has to be H2, but cannot be HP. To sum up, we get the failure of equivalent substitution principle just in classical logic system SCP only. When P is 1, P1 is 1, P2 is 0, and A equals B, but HA not equal HB. This result shows even in the classic, propositional logic, still has the nature of the principle, nature of the failure of the nature of the substantial. Okay, from this point, for the time limit, I can get a more complex result. So, if my idea is right, then I think not only the modular non-functional operator, just like necessary, can be reduced to the classical choose functional operator, but also we can know that natural language is safe and safety. For example, the obligation is not the necessary in some modular system, but necessarily good. Okay, there's a superposition of the necessary and the good, and I guess some operator believe maybe the 3 or 4 basically classical operations superposition. Thank you very much.
And now for the last talk, Pei Wang will introduce formal models in AGI research.